Hi, welcome back to my workbench. Today I'm taking a look at the Linear Technologies LTC4054 lithium-ion charge controller. It's a single-chip charge controlling solution with an absolute minimum of external components needed to implement a charging circuit. There were a few people who had questions on how do I revive a lithium-ion battery, and I figured addressing charging it with a very cheap and simple circuit would probably address that as well. I think a lot of their questions were really, how do I charge a lithium-ion battery, period? Because the included charge circuits with some of the equipment has a very high cutout threshold, far higher than lithium packs usually have to be. One of the other things you have to know about lithium packs is exactly what you're working with. So I know the characteristics of the batteries that I'm using because I purchased them and they actually have a data sheet and I'm familiar with them. One of the problems is if you're using a mystery lithium-ion cell, you shouldn't just apply a random charger to it. You have to know exactly what the voltage ratings and what the charge characteristics of it are before you start just randomly applying voltage. Otherwise, you could blow everything up. So, unless you're intimately familiar with the battery and its, a data sheet, you probably shouldn't just apply random voltage to random batteries. It's a bad idea. You usually end up in fire and regret. Anyway, if you enjoy these videos, please subscribe down below, give us a thumbs up, and let's see how this circuit works. So what I've got here is the charge controller itself is this little grain of sand over on the left here. The LTC4054, or, well, realistically this is probably a clone of the LTC4054. I'm going to assume it's a TP4058 from Top Power, likely. It works fairly well. It doesn't exactly have the same characteristics. If it is one of those chips, those have a lower overhead, although they're pin compatible and otherwise work in a very similar fashion to the LTC part. You can get the LTCs for, I couldn't find them at under $4. I don't know if they're just excessively expensive at the moment for whatever reason, if they're being phased out in favor of another part or what. The Top Powers and probably a decent quality Chinese version of the chip that purports to have the same characteristics and has a data sheet with it and all that. Those will run you about 3 to 10 cents, depending on quantity from a reputable supplier in China. So that's what we're using here, although this is suspiciously marked with the LTC numbers, but whatever. They work okay. I use them for the basic purpose I'm going to demonstrate here, and you can use the LTC part in the same fashion, or, a high-quality work-alike to the LTC in the same fashion as what I'm doing here. It's just a very useful style of chip. This is our 56K ohm resistor. I'm going to be soldering up some leads to these. They're just SMD components I happen to have lying around. Unfortunately, I didn't have any through-hole, which is why I'm using these, but you'll see in a second. I'll put up a diagram and a picture over on PCBurn, so it'll be a little easier to follow along if you want to see how the circuit actually works. Or and you can check out the LTC part sheet for the 4054. Their data sheet actually does have an almost the same circuit as what you'll see here. Here's a capacitor. It's a 1 UF 16 volt, just what I happen to have lying around. 16 volts probably higher than absolutely necessary, although I'm not sure they make a 16. Anyway, so 1 UF 16 volt, that should be fine. And our LIRC 2032 battery, it's a 35 milliamp hour nominal battery. It's got, which makes it a 28 is the absolute maximum of milliamps you want to charge it with, which is why we're going with this resistor, which will set our charge rate effectively at around 18 milliamps, which should be a very safe charge rate for the battery. That's what I was getting at with the importance of choosing the correct charge rate and knowing the correct charge rate and voltage for your battery. This will only work for a 4.2 volt chargeable battery. If your battery has a lower maximum voltage, this might cause it to explode. So you always want to understand the characteristics of your battery before you manipulate a charger together for it. This is a pile of extra components. I've got an LED for status, another capacitor, which will hold the, if we use this, it'll hold the charge port. Let me see my ports on here quick. Which port does it hold open? So this will get wired up in sequence with the charge port, and the capacitor here, the resistor and the LED, will get wired up in sequence with the charge port for status, and the capacitor here will get put in sequence with the battery so that it will provide a slight load on the line, if I'm remembering correctly, and actually cause the status LED to light up. Otherwise, the battery, if the battery isn't in, it won't do what you'd expect it to. But we can actually experiment with that. What I'm going to be doing is implementing this on a breadboard quick, which is why I've got these breakout boards. It's a TSOT23 and a little USB header, the only other components you really need for providing it with USB power. Let me get all this soldered up quick and pull it back in, and then we'll take a look at it. There's our components breadboarded, soldered, and ready to go. Let's take a look at how we're going to design this circuit, and then we'll go ahead and plug all the components in the right spot and see if it works. So here's the LTC4054 marked LTH7 on the chip. And let's just go and sketch out the circuit for this. Alright, so what you want to do is hook up the power with a capacitor in line to filter, coming into voltage in, which is pin 4, which on this chip is right here. So there's VCC. And we'll write our voltage in, which is going to be 5 volt, roughly. And then we've got a capacitor coming off here. And that goes to ground. So far so good. We're now supplying voltage into the chip. And we also want to hook up ground, obviously, from the chip. That's going to be pin 2, which is over here. And we'll take that and wire it to ground. So far so good. That's 2 pins wired up. Now we only got 2 more to go at a bare minimum. The battery and the programming pin. Battery pin is going to be pretty obvious. We want to wire that to the positive side of our battery, and then the negative side of the battery goes off to ground. It's pin 3, which is this pin. So we want that pin to go off to our battery. And then off to ground. Also, for our purposes, we're going to install an additional capacitor here that's going to go in line with the battery right here. I'm messing up on my space here. All right, and that's also going to go to ground. And that capacitor, if I remember correctly, is a 10 UF. So let me label that 10 UF. And we might as well label the rest of our parts in here. This is going to be 1 UF. Let's see, anything else? BAT. That's going to be a LIR 2032. And then we've got the program pin, which is pin 5 up here. Actually, let me number these pins. There's pin 5, pin 4, VCC, pin 2, ground, and pin 3 is battery. Our program pin's going to be using our 56K, is it 56K? Yes, 56K ohm resistor. So there we get the squiggly line for a resistor. $56K. And then to ground. And that's it. At a bare minimum, that's our circuit. And we've actually got an extra 10 UF here because we're going to hook an LED up over here. So this is the charge pin, which is the detection pin for charge. Pin 1. And that's going to have an LED coming off it. Now, I think this is correct. Let me wire it in here. We're going to do the LED like so. And I completely forgot the resistor, so we'll just pretend that I drew that in there originally. And there you go. So we're going to put a resistor here. I'm not sure what value to use exactly. I want it to be dim, fairly dim, but still kind of visible. I chose a 2.2K resistor initially, but we may have to adjust that as we go along. And there's our entire circuit. I'll just go ahead and go back to the breadboard and we can cut that in and check out how it works. As an aside, I don't recommend anyone use SMD components like this. Two reasons I was using these is because, well, one, they happen to be sitting right next to me on my workbench, so it was pretty convenient just to reach over and solder some leads on them. The other one was I was curious how well these ceramic clippers would hold for holding them in place while I soldered them, and that actually worked great. So for testing, creating some test components, these things were pretty boss for holding up my components while I was soldering them. Didn't run into much of a problem there. So that should be our basic test circuit all assembled. Or, you know, if you were designing this on a circuit board, you'd be done. Just a few connections over to the power incoming and the ground, and then a few connections between the components and ground over here, as you can see. Got some incoming power going to this power lead, and then a capacitor going over to ground right there. A resistor going from the programming lead to ground to program it for our nominally 18 milliamps of output. And then I've got the battery hooked up to the two battery leads, the output power and the ground, and then the central ground for everything else on this chip, and the ground coming in from the USB, and then the other ground going over to the other side where we grounded our capacitor and our resistor for programming. And then the power lead coming in right here. That's it. About 1, 2, 3, if you include the battery, 5 total connections, and 1, 2, 3, about 4 parts if you were to implement it on a board. Now, let's see how that works quick, and then we'll take a look afterwards and add in an LED, because I'm actually curious how these LEDs work. I haven't implemented one on here before, so that'll be neat. One moment, let me get this set up. And here's our setup. Our charge circuit is set up here with the battery, and then we've got a meter hooked up in line with USB to measure the amperage that it's drawing. And I'm going to check the voltage on the battery right now so we can get a feel for how charged it is currently. 4.013. That's actually really great. So these have been sitting on the shelf for quite some time. I'm surprised they still retain that much charge, but apparently they're pretty good batteries. Maybe we'll take a look at those at some point. And here we go. We're going to put the charger in. All right, there she goes. 0.01, 0.02. Let's see what our voltage is on the battery itself. And there we go, 4.08 and rising. So that's charging. Looks like the circuit's drawing the right amount of amperage. It's between 0.01 and 0.02, which is probably about correct with the amount of resolution that we've got in this little meter here. And unfortunately, it looks like that's probably about the most we'll get out of this. So I don't think we're going to get any more resolution out of our meter. But that's okay. It's in the safety range for the battery, and it should work just fine for charging it. Now, the one thing I did want to do is add the LED into the circuit, so let's pull this out again quick and see if we can make this light up. And I will pull the battery for a moment, just so that it's not connected while I'm doing this. Let's see, we wanted our voltage in with the LED in line. There. Now there should be power flowing through the LED over to the charge pin, which should draw the power if it's trying to indicate something. So that's all set. And there was also a note that you should add a capacitor across the battery if you're doing this to make sure that it gives a charge. Although I'm not sure if that's entirely necessary. I'm going to leave this off for now. I'll leave it down here, just park it. And then we can put it on afterwards if it doesn't act the way we think it should. Let's check it out. All right, so it's constant on when the battery isn't hooked up. The LED's doing something, so that's good. And let's see, where's our charge pin again? The battery charge is down here. 1, 2, 3, third pin. And it's charging, but there's no change in the light status at all. All right, let's put a capacitor in line. Hold on. Just going to unhook the power for a minute, and we'll put a cap in line here with the battery out. And I'm trying to think if they noted that should be as close as possible to the negatives on the battery. Don't know. But that's okay. This is all pretty beefy wiring. We'll just put it over here. Move the battery negative over next to the capacitor, and then hook that line over to ground. All right, so the positive, and now the negative from the battery is going to the other side of the capacitor, and that cap's going back to ground, so that should be good. We're back in, and we get the same thing on the status LED. I'm curious, this might go off once this is fully charged. I don't know. So I'm going to wait and see what happens with that. Actually, one other thing. Let me take the battery out and see. We'll just disconnect the ground on the battery. Ah, so there we go. The status light's probably working fine. Now the light's going out if the battery's disconnected. If you reconnect the battery and it starts charging again, there we go, just a bad connection. All right, and as you can see, it's charging up. The light's on when it's charging, and if the battery gets disconnected or it goes into low power state mode, the light should start blinking rather than being on steady. And that's it, just a very simple LRRC 2032 charge circuit for my quad cell lithium rechargeable batteries. It'll actually go up to probably a few hundred milliamp safely. So you could charge something like a 18650 on there. These are 1800 milliamp hours as opposed to the 32 milliamp hours of the little quad cells. Yeah, but they're also a 3.7 to 4.2 volt. So some of those, if they're the correct battery for the charger, those will charge just fine too. You just have to know what kind of batteries you're charging. Also, to the point some people were asking about if you could restore or refresh a lithium battery, what you're doing there is just charging it from a discharged state up to a nominally charged state if it's not defective. Circuits like this, and you'd have to make sure that the particular circuit supports it, of course, will charge up from a low power state, trickle charge it until it reaches a safe level, and then start charging it. So a charge circuit that's dedicated has all the support you need, and preferably is monitoring the temperature of the battery. This one in particular doesn't. You might want to get something a little more capable if that's your application. And it'll charge the battery up depending on if it's discharged deeply or not. It'll charge it, trickle charge it slowly, and then it'll apply a full charge whenever it gets up to a normal state that it can actually take a full charge in, so it doesn't, well, damage or explode the battery. That's kind of important. And these will handle the trickle charge portion of that without too much monitoring. You'd have to figure if that's right for whatever application you're using it in, of course. And there's the LTC4054 4.2 battery charger for lithium-ion batteries. Hope you enjoyed the video, and we'll see you next time.